Welcome to the middle of the Delta Math walkthrough. I'll do another example of this one. Here we've been asked to find how much this amount is going to be, and don't forget, round to the proper amount. So here are the calculations. You can pause the video if you want to see them. I'll do another example, don't you worry. Submit answer. Only time you can use a comma, right? So when you're copying from your calculator on your computer, don't forget that commas are only for points in Delta Math. Okay, submit the answer. Let's say yes. Hooray! Hooray, hooray, hooray. Okay, let's do a new problem. Okay, compounded continuously. Again, so same problem type. So let's go in here. We're going to write down everything that we know and then work towards what we don't know. So I'm just going to slide this over here. There. So Parker invests this amount of money, 7,800. His rate is 1.7%, which can also be written as 0.017. And to the nearest dollar, how much is going to be there after 11 years? So time is 11. So we're going to use the funky formula. P is equal to E to the RT, PERT. All right. So A is equal to P to the RT. A is equal to the principal multiplied by the number E raised to the power R times T. Okay. So the amount that's going to be there after 11 years is equal to 7,800 multiplied by E raised to the power RT. Okay. So it's 0.017 multiplied by 11. Okay, cool. All right, so now do that on a calculator. And if I want to do it just like all in one step, I would write it down from left to right, 700 times E raised to the power. See, it's going to do the Bedmas for me correctly here, I believe, if I put the power in brackets. 0.017 times 11, okay? Because I have to tell it do this multiplication first before you do that, because this has to be evaluated before I take the exponent of e times 11 and the bracket. So that's what is in the bracket there. This is the power that e is being raised to, and when I push equals, I should get an answer that Delta Math will accept. I also want to look at my answer and say, does that seem reasonable? And I've been asked to the nearest dollar, so I'm going to take that and add 1, because 89 cents is nearly a dollar. 89 is also a Fibonacci number. So here we go. There, and don't put in a comma. And here, I want to check, is that reasonable? $7,800 grew to $9,400. It's not like it's a little more than 10%, and we had a little more than 2%, a little less than 2% there. We had 11 years. This seems really right. Let's see. Yay! Okay, let's find one that's not compounded quarterly. Sorry, compounded. There we go. Compounded daily. Okay, here. We haven't done an example like this yet. So let's take a look. Oh, yeah, that's fine. I'll move this way up here and way out of the way. And now let's go for it. Let's zoom back in, actually, because otherwise my pen will be very small. Okay, so we are investing. Write down your numbers. Here is the principal. P is equal to $97,000. So we got a real amount of money here to invest. That's good. That's like, if you make that in a year, you're doing well in our society. Okay, and 6% compounded daily. So the amount, so the interest rate is equal to 0.06. The C, this is the compounding period. Well, there's 365 of those days in a year. So we use 365. I'm not actually sure what banks do with leap years. Some of you might be sitting there thinking, well, Mr. Jennings, not all years have 365 days. So I think actually in a leap year, probably to do this precisely, you would use 366. It's not going to make that much difference anyway, man. Okay, so let's keep going. Okay, how much will be there after 10 years? So time is equal to 8. Okay, so let's find our interest rate per period, per compounding period, and that's R over C. So we will just know that that's this. So I'm going to actually do this up here, is equal to 1.06 divided by 365. Why would you use a decimal approximation here when this is so clean to write down? Okay. And then the number of compounding periods is based on these two numbers, and that's 8 times 365. And that should make sense. We're earning interest every day, and we do this for 8 years. So the number of times we earn interest is 8 times 365. Okay, so now let's drag our whiteboard over the question. We'll get some space to work, and we can spread out our ideas on lots of paper. Okay, so now the amount that's going to be here at the end of all of this is going to be equal to the principal multiplied by 1 plus the interest rate, this number, raised to the power n. Okay, maybe this is like the amount is equal to pin. Maybe that's how you remember it. The amount is equal to pin. Okay, so I'm going to sneeze, but now that I've said so, maybe I won't. Oh, it's so painful to be just on the edge and not sneeze. Okay, I did not sneeze. Okay, 1 plus. Newsflash, I did not sneeze. This. Okay, 1 plus. Ugh, I 0.6 over 365. This is all just goes into a calculator. Like I would not do that. But that, let's write that number down. 8 times 365. Clear. How many days are in 8 years? Mr. Jennings, should we add 2 to this because there would of course be 2 leap years in there? No, I don't think we need to do that. Okay, 2920 raised to the power 2920. Mr. Jennings, that is such a big number that we're raising this exponent to. Won't this number become huge? Yeah, but this number is so small that they cancel out, okay? So, all right, let's just do it on a calculator. A is equal to, and I'm going to move this over here so that I can write it all down in my calculator. Okay, here we go. Use my mouse as fastest. Clear. Or 97000 times bracket 1 plus 0.06 divided by 365 end bracket raised to the power. So see, it's doing the Bedmus correctly for me. This times this raised to is waiting for me to tell me what exponent to raise this to. 2920 equals this amount. Okay, so there we go. So that is our answer. So there, and we've been asked to give this to the nearest cent. Okay, so let's take this answer. There is to the nearest cent. Copy that and put that in there. And remember, Delta Math don't like commas. Yay! Okay, so that's how you do these types of questions, solving for the amount. Let's take a look at some other question types. Solving for time. So I put the bitter pill earlier. All right, so let's do some solving for time here. All right, Jackson. He's got a very cool X in his name. So we're going to gather our numbers and then work on the, oh, that's not what I want. There, okay, so the amount he invests, so the principal is equal to 960. The rate is equal to 6.1%. The time is unknown, so that's what we want to know. Time equals question mark. Important to note, that's what we're looking for, solving for time. We don't know how long it's going to take for the amount that he's got available to equal $1,720. And maybe you're like, Mr. Jennings, I'm already bored and I don't care. Well, here's one trick that you can use. You can say, $1,700, what would I use that for? I would buy myself a fancy new gaming computer so that I could play Fortnite all day. Okay, all right. Well, if you want that, let's say you have this and this is available to you. Let's see how long it's going to take you to get that gaming computer. And maybe now you care a little more about it. Okay, all right. So let's go ahead and work this out. Oh, and C, compounded monthly. So our C is equal to 12. That's the number of compounding periods per year. All right, let's go for it. So here we go. Yoink. Okay. So we are going to do as much Bedmus as we can, and then we could Desmos it. Let's Desmos it rather than guess and check. Because you're at home, you can Desmos. Okay, so the amount is going to be 1,720 is equal to the principal, which is, let's write out the formula here. A equals P times 1 plus I. Oh, I need to calculate I raised to the power N. Oh, it's hidden by those darn buttons. N. Okay, so I is equal to 0.061 divided by 12, and N is equal to T times 12. Okay, so that's what we've got. So let's write it out. Equals the principal, which is 960 multiplied by 1 plus 0.061 divided by 12, and then that's going to be raised to the power 12t. Okay, now you could do this as a power of a power, and you could find out what this to the 12 is, and then that would be raised then to the t, and you could solve for it, or you can just work with this in Desmos, and I'll show you how. This is an exponential function. We could call a new function f of x is equal to, or f of t, sorry, is equal to this, and find out when does it equal that. So that's how I'm going to solve this problem. So I'm going to put this over here. I am going to make Desmos this size so that I can write that in. Okay, so a new function, and I'm just going to use x because Desmos likes x's instead of t's, and I'm going to solve for x, and then I'll know that's the amount of time. Okay, this is equal to 960. I could divide that out and do all the Bedmus like I said I was going to, but this is just as easy. Okay, times 1 plus 0.061 divided by 12, end the bracket, raised to the power 12x. Okay, now I want to change the scale and all of that stuff so that I can find the useful information. I want to know when this is equal to, sorry, I just forget how much it's supposed to be, 1720. Okay, so I'm definitely going to want 1700 on my y-axis, so let's make this go up to 1800. All right, and then we're already seeing it over there. And then let's get the, where is it? Let's put it up to 2000, it's just easier. 2100. Okay, there. All right, so there. And now I can get the x-axis on there. It's a little nicer. And I can graph the line y equals 17. What was it, 1720? Oh my goodness, people are yelling at me. Yes, 1720, Mr. Jennings. There. So there's our solution. All right. It's going to be at 9.58 years. This is going to be when we have enough money. There. And that looks reasonable, right? Here's money, and it's growing exponentially. Let's get excited. Let's look at more time. See, the slope increases because exponential. So the more time you have, aka if you're young, or if you're banking on cryogenic freezing, then the more exciting having more time is to you. Yeah, if we invented a good way to cryogenically freeze people, that would really do a number on our economy. Like, I don't know what's going to happen to inflation and what's going to happen to all that stuff. It's probably South Park episodes about it. All right, so let's input that number. What is that number again? 9.584. Let's see. Delta Math said, how long would it take to the nearest years? 9.584, so 10 years. Submit answer. We could have gotten it by guess and check because they wanted to the nearest year. That wouldn't be that hard to guess and check. Yay! So let's see what they do. Take the log of both sides. Yeah, so they think we have done grade 12. Ha ha ha. But little do they know we're using our fancy grade 11 methods that still work. They're just fine. You just need delta math. You just need Desmos, because that's how you solve for time. Okay, solving for the principal. All right, solving for the principal. We've already looked at examples like this. I'm only going to do one, and we're going to go faster now. Okay, so get our numbers first. 1.9%. The C is continuous, So this is equal to our rate. How much would he need to invest to have the amount reach 530 after t is equal to 7 years? Okay, so we're going to use our continuous interest formula, and we're being asked to solve for how much money does he need to invest right now. Why does he need to do that? In 7 years, he knows that he's going to need $530 to buy himself the cheapest used car you could ever imagine. Okay, this is a question for 9-year-olds, and on their 16th birthday, they want $530 so that they can buy themselves the cheapest used car you can imagine. Okay, so let's use it. We're going to use our continuous interest formula. A is equal to P multiplied by E raised to the RT. Okay, and then we're going to write in our numbers. 530 is equal to some number P multiplied by E raised to the R times T. R is writtenable as 0.019. Okay, so this is 0.019 multiplied by 7. Okay, that's T. All right, now divide both sides by this. Okay, divide by this, so that you get the formula 530 over e to the 0.019 multiplied by 7. That's the answer we're looking for. Punch this on your calculator. Okay, so let's go do that. We're going to move that over there so we can still see it. We can punch it on the calculator. Move that up here. Clear everything out of your calculator, and there's nothing in memory, so that's great. 530 divided by e raised to the power, bracket the power, 0.019 times 7. End the bracket. That's the power that e is being raised to. Push equals, and it tells me $463.99 to the nearest $100. That's so, I could probably tell you it's 500, isn't it? What was it? Yeah, it's 500. Yeah, it's like, just like I look at the question, I can just answer it. Okay, so it's 500. All right, that's crazy that they're asking us to round to the nearest $100 because we need way more accuracy so that Brooklyn doesn't have to waste money investing to buy that used car. Okay, submit answer. Enter. Yay, hooray. Okay, see, A is equal to PRT. We put in those values. We divided by this, and we found that it is about $500. Way not accurate. Okay, and then compounding, solving for the rate. All right, Ella is going to need to invest this much, and this is we're actually going to spend a little more time with this because to solve for time or to solve for the rate, we actually have a bit more bedmas to do. Okay, so let's get our numbers. Let's not work with the purple pen of pain. Let's work with the blue pen of boisterousness. All right. So she's going to invest. P is equal to $1,100. Okay. She's going to leave it there for T time is 16 years. Okay. Assuming interest is compounded monthly, C is 12. Okay. At what interest rate? Rate is equal to what? What is the interest rate to the nearest hundredth of a percent would require for Yella to the nearest hundredth of a percent? They want a lot of detail here. It's so weird. They're rounding in order for her to end up with an amount of 1,400. Use your formulas. Okay, a lot of great algebra workout today using your formulas. Here's how this one would work. I know that amount for some investment compounded monthly is going to look like this. It's going to be the principal multiplied by 1 plus the interest rate, which is the R divided by 12. So that's something that we're going to have here. R divided by 12. Raised to the power T times C, which is N equals T times C, which is 16 times 12. 16 times 12. Gosh. Geez, why is that so hard for me right now? 160 plus 32 is 192. Yeah, 192. Yeah. So this is all to the power 192. Okay? So let's write down everything that we know. Let me just erase some of that really rough work there. Okay. So, hello, mister. The amount is, notice this is going to cancel this. No, I'm not going to have you notice that. I'm just going to write it down. 14, 000 equals 11, 000 multiplied by 1 plus r over 12 raised to the power 192. This is what we're trying to solve. So you can think of it like the enemy's weak point, and this is armor, and even the stuff inside here is internal armor or something. And you need to find the weak point, the chink through all the armors to find that number. Okay? And the way we do it is by peeling back layers of armor. The first layer that we can peel back is divide both sides by 1100. The loose multiplication out there. And then we get 14 over 11. I told you they would cancel, but I wrote it down anyway. This is equal to 1 plus r over 12 raised to the power 192. Okay, we can't get inside to that bracket yet. It's being protected by this exponent. So what we're going to do is, using the rainbow pen of miraculousness, is we're going to take the 192nd root of both sides. I've never taken the 192nd root of anything before, but there's always a first. Okay, so here, let's do that. So if I have here, I'm going to clear everything. Okay, I am going to be punching this on the calculator here. The 192nd root of 14 over 11. 14 divided by 11 equals. Now, take the, I think it's inside my second yet, there it is, the y-th root of this. So the y root is 192 equals. So there. This number, when multiplied by itself 192 times, will give you 14 over 11, according to my calculator. I actually thought it would be closer to 1, but here we are. We're all being surprised today. So now, this number is equal to, just go ahead and write another line, Mr. Jennings. The 192nd root of 14 over 11, I'm not writing down the decimal approximation, I'm still writing down the exact value, is equal to 1 plus r over 12. Okay, because we got rid of this by taking the 192nd root. So now, this is like an easy thing that we used to solve quite a lot. So to solve that one, I am going to first subtract 1 from both sides. Okay. And so then I will have the 192nd root of 14 over 11 minus 1, and that's going to be equal to r over 12. And then what I'm going to do is multiply both sides by 12. And that will give me r. This will give me r. Okay? So I've already calculated the 192nd root of 14 over 11. It's here. And now, remember those questions? When am I going to use this stuff? Well, here. It's like, when am I going to need to take these weird, funky roots and stuff? Well, you're going to take the funkiest, weirdest roots in the finance unit. I'm going to subtract 1 from this number. And that's going to be equal to this. Then I'm going to multiply that by 12. And that's going to equal this. And this is the interest rate I need as a percent. As a decimal, sorry. So it's cool. 1.51% to the nearest hundredth of a percent will be 1.51%. Okay, so R is equal to 1.51%. Okay, lots of detail. We got it to the nearest hundredth. Cool. All right, and now let's punch that in. Does it want me to punch it as a percent or 0. I'm going to write it as a percent. 1.51. Hooray! Hooray. So, yeah, it's about equal to that. Cool. So that's how you solve for the rate. Okay, let's do another one. All right, Sarah's going to invest this much money. Oh, Sarah, it's very wise of you to invest money while you're so young. I'm not sure if Sarah, if you're still here. All right, so let's get our numbers. The principal is equal to 280. The amount that we want is 410. Okay, so we want not to double it, but close. Okay, we are getting the interest. It's compounded continuously. So it's actually going to be a little easier to solve, but we're still going to use a funky root. Okay, what interest rate? The time here is 9 years. And what interest rate does she need to do this? I'm going to guess 6%. But you see, I'm like really like, I'm not really sure. Wait. Maybe a little less, maybe a 5 or 4. Okay, somewhere between 4 and 6. Okay, that's like I give myself a bit of margin for error, and we're compounding continuously. Okay, so here's what we know: the amount is equal to P multiplied by funky number E raised to the power RT. All right, we don't know R yet. We know T. Okay, so let's do it. Okay, so A is 410 equal to 280 multiplied by E to the 9R. All right, so what value R do we need here? So we're going to, again, be going to Desmos to find these. Okay, so here, we can go to Desmos right away. Sure, let's do that. Okay, so put this over here so we can read it off and find it in Desmos here. Boop. All right, don't. And then we're going to have sum f of x. Oops. Sum f of x. No, little f. Some function is equal to 280 multiplied by E. E is inside my little buttons here for Desmos, which are hidden by the way I've laid out the windows, darn it. Come on, man. Here, if I do this. And then this follows it annoyingly. There we go. So where is the letter E? Does it just know E? E. Yeah, it does know E. Okay, good. Desmos knows these things. Of course it does. It's E to the 9x. Okay. And I want to know, after how many x does this equal 410? So let's put in the number 410. And then let's see. Okay, yeah, 410 equals y. All right, we find this point of intersection. Okay, 0.042. Oh man, that can't be right. No, it can. Yeah, that's the interest rate. Yeah, that's an interest rate. Yeah, that's the interest rate that we want. It's 0.042. Okay, there's 4.2%. Hooray! Hooray. Yeah, always know what kind of numbers you're looking for. And I said it's going to be between 4 and 6%. And it is. I was like 6%. And I was like, no, it should be lower. Maybe even as low as 4. Cool. I made a good guess. 4.2%. Let's put it in. To the nearest tenth of a percent. Well, I can give you the nearest tenth of a percent, Mr. Desmos. Very cool. Very cool. So that's how you do it. All right. Compound and compare accounts. Okay. These, I already showed you an example of compare in the earlier thing. But here, if Matthew and Peyton both invest the exact same amount of money, but one of them gets 3 3/8% compounded monthly, and one of them gets 3 1/4% compounded continuously, how much more money will Matthew have? Yeah, so I'm getting the feeling that Matthew's going to have more money, not only from that, but just by the fact that that's significantly higher than that. And compounding continuously doesn't give you that much better of a return than compounding monthly. You're already pretty close to the optimal by compounding monthly. Compounding daily is slightly closer to the optimal, but it's so close to compounding continuously that it might as well be. And compounding annually is a fair bit lower than compounding continuously. Compounding 12 times in a year is much better than compounding once. Okay, so do the math for both, and then use subtraction to find the difference. And that's the answer that Desmos wants here. And it's 9:30. I am done doing Desmos walkthroughs for you, everyone. Okay. Bye for now, everyone. I'm going to go in and lower the amount of questions required for this Delta Math assignment right now.